All right, so we have been playing around with some graphs and exploring them using technology. It's time to put some paper and pencil together and see what we know about graphs. So a little review, you should have done some activities for linear graphs, and you should remember that a linear graph makes a straight line when it's graphed, and it has an equation in a form like that. Y equals mx plus b, where m is the slope, so that's how steep the line is, and b is the y-intercept, where it crosses the vertical axis. Other important terms with linear relations are words like rate of change, and rate of change is really just related to our slope. So you can have a positive or a negative rate of change or slope. A positive slope goes up to the right, and a negative slope goes down to the right. Other things about lines, you can have an x-intercept as well as a y-intercept. So you can have a point where it crosses the x-axis as well. So remember that there is also an x-intercept. So all those things should be reviewed from grade 9 and 10. We are going to take a look now at some new graphs from exponential functions. That just means a graph that has x in the exponent. So you should have done that little sheet of graphs using Desmos at this point. And after doing that sheet of graphs with Desmos, you should recognize that an exponential graph, so an equation that has an exponent with the x, has two basic shapes. It's going to curve up if it has a base that's greater than 1, and it's going to curve down if it has a base that is a fraction. So those are the basic shapes for your exponential graph when you have an x in the exponent. Where that takes us, it's all good to use technology to make a graph, but we're going to talk about here in a few minutes about how we can graph without using technology, so we don't need to rely on Desmos. A couple of things to notice about your exponential equation. So when you have an equation in the form of y equals ab to the exponent x, that is an exponential relation, and it'll make the shape we just talked about, that nice curve that curves up or curves down depending on the base. The number at the beginning, the a value, is called the initial value of the function, and b is the rate the relationship is growing. It's the base. It's how quickly it's increasing or decreasing. To graph, one of the things we can do so that we don't rely on technology is to make a table of values and then plot those points. You should have practiced with points when you were reviewing the linear graphs on Desmos. So if I want to make a table of values, if you played around on Desmos, you probably found the table of values there as well that every equation creates. If I'm going to make my own table of values without relying on technology, I'm going to start with a nice little t-chart, and I'm going to title one column X and one column Y. And then in my t-chart, every time I'm going to put two negative numbers for X, 0, and two positive numbers for X. Then to fill in my t-chart, I take each X number and I substitute it into the equation. So the equation is Y equals 2 to the X. Instead of X, I'm going to put each of the numbers in my X column. So for the first one, I'm going to put 2 to the negative 2. And we learned about negative exponents. We learned that a negative exponent flips the base around and makes the exponent positive. So the answer to 2 to the negative 2 would be 1 over 4. Now I've given myself an ordered pair. So there's the pair I'm going to put on my graph. I'm going to go over to negative 2 on the x-axis, and I'm going to go up 1/4 of a space. And now I'm going to figure out the next one. So this time I take out the x and I put in -1. I know about negative exponents. It means I flip over the base and I make the exponent positive. And 2 to the exponent +1 is just 2. So there's my next point. I'm going over -1 and up a half a space. And I'm going to keep doing that all the way through. Next time, I'm going to take my equation to the x, and instead of x, I'm going to put 0. And we learned that anything to the exponent 0 is 1. So there's my next point, 0 and 1. And then I do the next one. Take out the x, put in the 1. 2 to the exponent 1 is 2. And the next one, 2 to the x, take out the x, put in 2, and 2 to the exponent 2 is 4. So that now I have a whole bunch of points. And I'm going to put on my graph. Oh, there's my graph. Move my graph up a little bit so that's closer to my table. There we go. And I'm going to put a little bit of a scale on my graph. 1, 2, 3, -1, -2, -3. You should always have a little bit of a scale on your graph. 2, 3, 4, -1, -2. Okay, so I'm going to put my points on. I'm going over to -2 and up a quarter of the way. And then I'm going to go over to -1 and I'm going to go up half the way. And then I'm going to go 0 and up 1, 1 and up 2, and 2 and up 4. And you can see that lovely little curved shape taking form. Some things you should have noticed about the graph that I did not do a good job of because my pen was so thick. When you graph these, they never cross the x-axis. This means the x-axis has a special name called an asymptote. An asymptote is an imaginary line, a line on a graph, where the curve does not generally cross. So in this case, it's the x-axis. Because whenever I have an exponent, I'm always going to end up with an answer that's greater than 0. So my graph will stay above 0. All right, let's do another one. So if I have 1/2 to the x, I can make my nice table. Let's see if I can do a straighter line this time. My x, my y, same deal every time. -2, -1, 0, 1, 2. This time my equation is 1/2 to the exponent x. So for the first one, I'm going to take out the x and put an exponent of -2. We know that negative exponents flip the base and make the exponent positive. So I really have 2/1 to the exponent 2. And 2/1 to the exponent 2 would give me 4. And there's my first point, over -2, up 4. And now I do the -1. Take out the x, put in the -1. Negative exponent flips the base around. So I have 2/1 to the +1, which would just be 2. Next one, instead of x, I put 0. Anything to the 0 is 1. Take out the x and put 1. Anything to the 1 is just itself. Take out the x and put 2. Anything to the exponent 2, or 1/2 to the exponent 2, would be 1 to the exponent 2, which is 1, and 2 to the exponent 2, which is 4. And there's all my points. As you get good at graphing or confident with graphing, you do not have to show all of that. So you can do that in your head if you're good at it and confident that you know what the answers are. So I'm going to find my graph again, move it up here, and we'll put our points on. So same deal, I'm going to put a bit of a scale, 1, 2, 3, 1, 2, 3, 4. All right. some points on. I have got the point -2 and 4. And I've got the point -1 and 2. And I've got the point 0 and 1. And 1, or sorry, 1 and 1/2 and 2 and 1/4. And there's our nice little curve shape that we talked about before, curving the other way this time because the base is a fraction. So one of your jobs is to remember that a fraction base decreases and an integer base increases. So basically 1 goes up and 1 goes down. All right, last one. We're going to go quicker because we've already done 2. Only difference with this one is that number in front. That means I've got my power and then I'm going to multiply it by 3. So my equation this time is 3 times whatever 2 to the exponent is. So I've got -2, -1, 0, 1, and 2. So I have 3 times my 2, and instead of x, I've got -2. And remember, 2 to the -2 from over here, 2 to the -2 is a quarter. So I'm going to have 3 times a quarter. Whoops, I'm running out of space, sorry. And 3 times a quarter is 3/4. And then I'm going to have 3 times 2 to the exponent -1. And remember from over here, 2 to the -1 is 1/2. So I'm going to have 3 times 1/2. And 3 times 1/2 is 3/2. 3/2 is the same as 1.5, and 3/4, if you're having trouble, is the same as 0.75. That might help you with the graph. All right, so I've got 3 times 2 to the exponent 0 this time. Anything to the 0 is 1. So I have 3 times 1, which means I have 3. And then I've got 3 times 2 to the exponent 1. So I have 3 times 2, which means I have 6. And last one, I have 3 times 2 squared, which is 3 times 4, which would be 12. So when I go to graph this one, I'm going to need much higher numbers on my y-axis because my y numbers go up to 12. So 1, 2, 3. I do not need to use the same scale on both axes. So 2, 4, I'm going to do 6, 8, 10, and 12. And then I'm going to put my points on. Oops, I need to move my, see my points. -2 and 0.75. -2 and 0.75. -1 and 1.5. 0 and 3. 1 and 6. And 2 and 12. And there's our lovely shape running along the x-axis, the asymptote. And it is increasing because the base is 2. It's not a fraction. And it increases more quickly, interestingly enough, than the first one because it's multiplied by 3. All right, so that is graphing using a table of values. There are questions to follow. Make sure you do those practice questions.